headset to be turned off after all that. So looking at 1 through 8, are there any questions on those there? So I'll just pick some at random. So 3, C, 3, 4. So if we look at C, we're going 4 over, which would be 8. Because it's C, third row, fourth column, and that's our element. So if we looked at, say, number 5, B14, would be first row, fourth column would be 0. And that's it. That's all we're doing on these. Over, down, and over. 9 through 12. Let's just go on, start at 9. It would be what? And the B is 1 by 4. D is yeah, so be paying attention on which ones it's asking. It might not go A through whatever the letters are, because it went A, B, D, C. Okay, let's click on the correct keyboard. Perform the indicated operations if possible. Because what do we have here, A? It is possible. This does work, because we're doing our over and down. Now we could do this by hand, or we could do this in the, because I could set this up as matrix A and this is matrix B. And multiply them together. Do we want to see this done by hand or in the calculator? Okay, we can do both. Because we're going to go over and down, which would be 6 times 9 plus negative 7 times 1 plus 4 times 0. We'll do it again. We'll go over and down, which would be 2 times 9 plus 8 times 1 plus 10 times 0. Well, 10 times 0 and 4 times 0 is just 0. 6 times 9 is? Yeah, 6 is 54 minus 7. 2 times 9 is 18. And 8 times 1 is 8. 54 minus 7 is? And I believe we got the same thing on the calculator. Because in the calculator, so we can do second matrix, go over to edit, and it is a 2 by 3, 6, negative 7, 4, 2, 8, 10. Then we can go second matrix, over to edit and down to matrix B. And this is a 3 by 1, 9, 1, 0. At this point, we can go second quit, second matrix A to pull up the first matrix, second matrix B, and we could put them right next to each other because we are multiplying, and it would be 4726 in a 2 by 1. Any questions on this here? Mm-hmm. 14, so we're adding and subtracting, yes? Now this is a 3 by 2 and a 3 by 2. So if we were doing this by hand, we would first apply the scalars and then add or subtract the two together. Now, if we do this in the calculator, well, the first thing we're going to need to do is to define the matrices. And the first one is a 3 by 2. 8, -4, 10, -20, 4, and 16. So we have that typed in. Then we can go second matrix, edit, B. It is also a 3 by 2. -1, alpha, y equals, enter, 1 over 3, 10. Nope. Did it again. It would be 0, 2, 2, and 4. I about started to put the first one in again. So if there's no questions on how we put this in, what we can do next is, well, we have what? 1/2. So I can go 1 alpha y equals enter, or I could say alpha y equals enter and then type the 1 over 2. Either way works, because we'd have 1/2 times what? Second matrix A, because we want to put A in first. Minus 3, and then we want second matrix B. And then we can hit enter. And it gives us the matrix. Because if we did it by hand, we would multiply the first one by all the elements inside of it by 1/2. And the second one, we would multiply it all by -3, and then add the 2 together. Questions on this here? Any other questions on 13, 14, 15, or 16? We could type this into the calculator because we can define this as matrix A and type it in as 14A, and it would give us the answer. Really what we're doing is we're multiplying every element in that matrix by 14. So 2 times 14 is 28. 14 times -7 should be -98. 14 times 8 is 2, carry the 3, I believe 112. Then we would have -14, 112, 14, 56, 56, 196. 6 times 14 is 84. Well, we'd have 84 over here. And then -42 this here. So we can multiply each element by 14, or you plug it in the calculator, do the same thing. Any questions on 15? So what do we have? We have A and A. So the dimensions are the exact same, yes? Now, if you typed it in, both of them, I believe it says invalid dimensions. It pops up an error saying invalid dimensions. It doesn't work. We can't add or subtract them. Questions on this here? Questions on 17, 18, 19, or 20? Same thing, yeah. Because 17 would work, because here we have a 1 by, so columns of the first match the rows of the second, so it would work. What would the new dimensions be? a 1 by 1. And I believe, because I remember this yesterday, it's 352. Yeah, on the answer key, there's a weird space between the 5 and 2. Don't know why. But it should be 352. I fixed the key so it does look like one number, not look like 35 and 2. But it is one number, 352. Any other questions on these here? 20? Okay. Yeah, 19 is not possible because we have a 2 by 2 and a 3 by 2. Since the dimensions are not the exact same, it doesn't work. 20? Subtract and add. Okay. So we could type it all in, or if we did this by hand, because negative 207 minus 196 is going to be negative 403. 14 minus 108 is going to be negative 94. 19 minus 2 is 17. 106 minus 14 is 2. Negative 7 minus 107 is 100. 98 minus 29 is 9,369. 106 minus 86 is 20. And 2 minus 107 is negative 105. Okay. 14, 8, 7, 4, 2, 1, 8, 0. At this point, we add them together, so negative 403 plus 14. 9 would give us 23. 8 would give us 100, so negative 389. Negative 94 plus 8 is going to be negative 86. 17 plus 7 is 24. Then we would have 96, 102, 70, 28, and negative 105. Would y'all agree with that there? Awesome. And really, we could have set this up as A, B, and C in the calculator, and did A minus B plus C, and gotten the exact same thing. Questions on 21, 22, 23, 24, or 25?
Can we do one of
21. Well, for these two to be inverses, A times B should give us what? Because if we get anything other than the identity, then the two matrices are not inverses. So really, what are we doing? Multiplying these two matrices together, yes? We can do multiplication in the calculator, yes? So I'll do this by hand, as y'all do it in the calculator, because we've seen it once, because we'd have 7 times 1/4, or 7 times 1/7 is 1. 7 times our 1/7 is 1. 4 times 0 is plus 0. We'll go over and down again. 7 times negative 2/7 would be negative 2. Plus 4 times 1/2 is plus 2. Over and down. Well, 0 times 1/7 is 0. 2 times 0 is plus 0. And the last one over and down. 0 times negative 2/7 is 0. Plus 2 times 1/2 is 1. Which gives us the matrix 1, 0, 0, 1. So are they inverses?
Yep.
Yes. So for those that typed it in, so you went second matrix over to edit, matrix A, and did a 2 by 2, yes? 7, 4, 0, 2, yes? Second quit, second matrix A, inverse, I don't like that. Multiply them together and that works, yes? What did I just do?
Oh, you just did the,
What did I find? I found what A inverse is, the inverse of A, yes? Is that the exact same as what B is?
yeah. So if that happens, then you know it's yes, right?
So I found out what the inverse is. A's inverse is 1/7, negative 2/7, 0 and 1/2.
Which is what?
Mm-hmm.
So therefore you should.
So if A inverse is B, then they should be inverses. Or if B's inverse is A, then they are inverses. So we save a little bit of time, but if you want to make sure, we can always just multiply them together and get the identity. Or if I just find out what A's inverse actually is and match it up with the other matrix, we can figure it out as well. So this here, the matrix A, and then took its to the -1, its inverse, enter. So that's the inverse of it. But because it's going to give us it's going to give us the answer in fractional form, decimal form, not fractional form. That's why we get these bigger numbers. And it went math enter, because the first option is fraction. Enter, and it'll give us this here. Now, fractions, you can ask, how do I turn it into a fraction? I'll tell you, math, enter, decimal, yeah. Because that's not testing the concept, that's number, type it into the calculator. Questions on this here? Let's look at 26 through 29 then. Which 26 through 29, which one do we want to look at? Because 23, I believe we figured out that this is actually yes. The answer key is wrong. This one is yes. Mm-hmm. And I believe that this one is no. Should not be. Mm-hmm. Yeah, I have a feeling when I wrote the key, I flipped those two because I think I went 21, 22, dropped down 23, 24, which actually 24, 25. So I think that's how I got those flipped. So let's look at the inverses. So if we do this by hand, what we're doing is 1 over AD minus BC times the matrix D negative B negative C A. because A and D switch places, B and C we switch the signs, and we multiply it by its determinant, 1 over the determinant. Now this one will definitely have an inverse, because the only way for it to not have an inverse is if the determinant is 0. So most likely AD minus BC, well really AD would have to equal BC. Now since I know that one of the numbers or elements is, that means one of those is going to be, is the other going to be 0? No, because it's 27 times 2, yeah? So most likely it's going to have a determinant. So if we type this in, or plug this in, it'd be 8 times 0 minus 27 times 2. Times the matrix, well, A and D switch, so we'll have 0, 8, and negative 27 and negative 2. Well, 8 times 0 is 0. 27 times 2 is, and this whole thing is going to be, all right, let's start off with the most challenging one first. Negative 1/54 times 0 is, okay. Negative 1/54 times negative 27 because our determinant was 27 times 2. Now, negative 1/54 times negative 2 is going to be 1/27th. And lastly, we would have negative 4/27. Because 8 is 4 times 2. Well, the 2 on top and bottom with the 54 would cancel. 27's only factors are 3 and 9. So that's as simplified as it gets. Questions on this here? Yes. Because in the calculator, we can go second matrix over to edit and edit matrix A. Now, the only matrices that will have an inverse are square matrices. They have to be square. So 8 and 27. Yes. And I've done that before. Started typing it at the very top, the dimensions. Now, once we get that typed in, we can go second matrix A to the negative 1, which is going to understand to be inverse. It won't represent as a negative power. And we can go enter, and we get these lovely numbers. Math, enter, enter, and we get this here. Because 1/27th and 4/27ths are not real nice numbers. So this year we'll turn them back to fractions. And that's it. Any other questions on inverses? So there is a chance that there might be some that are not possible because the determinant is 0. Because if the determinant is 0, then we cannot have an inverse. It is not invertible. Does that make sense? Not possible. And if you want to make sure that you do put it in right, just go on and take the determinant of it or cross and see. Because if you take the determinant, okay, the determinant is 0, it is not possible. If it comes up that the determinant is not 0, look back at the matrix and make sure you plugged it in right. So, any other questions on the inverses? That brings us to the last page, 30 through 35, yes? We could plug these into the calculator if we wanted. Now, the 2x2s are the ones that really, doing it by hand and doing it in the calculator really isn't saving you any time. Because we're going to take negative 7 times 8 minus 14 times 21. Now for the homework assignments, there's several, and I mean a good number of y'all need to be careful with the sign, because it is subtraction between them. The only way that this turns to addition is if this, the sum or the product of these two numbers, is negative. Here, this would be negative 56. This 350? Okay. Yep. Negative 350 would be the correct answer. And this should be a 9. Mm-hmm. Yes. Because if you notice that on all of these here for 30 through 35, we do not have brackets, we have absolute value bars. That is another way to write determinant. We're saying taking the determinant. Also in the directions, find the determinant of each matrix. So we can do that. Now, 32. Let's look at 33, because 33, 34, and 35 are going to be about the same, because we can do it the same way by hand. We can write the two columns out and do our diagonals multiplied together going from left to right, add those together, and subtract from it the sum of the diagonals going from right to left. Now, this one here, it does work out that it's a lot easier and a lot faster to do it in the calculator. For this here, we can go second matrix A, which is going to be a 3 by 3. 8, 19, 3, negative 6, 4, negative 2, 15, 0, negative 1. So we want to enter the whole matrix in first. Now we can go second quit, second matrix, but this time we're going to go over one to math, because the first one, DET, is our determinant. Then we can go second matrix A, enter, and it gives us the answer of negative 896. And that's it. That's all we have to do for these determinants. And that's it. Now, a question like number 35, you can do it by hand, but because that is a lot of fractions, and not all the fractions will wind up having good denominators that you'll end up having to convert or use the calculator for. And most likely you're going to be plugging each one of those diagonal multiplications into the calculator anyways. Might as well let it take the whole thing. It's going to be about this here. It's not going to be too bad. Only one part. Any other questions on any of this here? Now, you probably noticed that Kramer's rule is not on here. Solving by inverses is not on here. It is not on the test. Because I wanted to go over to show y'all these are ways that we can solve systems. They're not effective ways to solve them. There are other ways that we can solve them that are a lot more effective. But that